Alright, let's solve another system of rational equations. Each one we do is getting a little bit more complicated, so watch out. So here again, we can start off by setting these equal to each other because they both equal y. So that's going to create x squared plus 5x plus 6 over x squared plus 4x plus 3 equals x over x plus 3. So let's factor and see what we've got. Now I'm only going to factor the denominator. I'm only going to factor the denominator because we just need to have like denominators, that is all. But something might cancel out. I better factor the numerator too, just in case something cancels out. So let's see, if I factor this, I'm going to have x times x, 6, okay, is either going to be 2 times 3 or 6 times 1. Thinking ahead, I think it's going to be 2 times 3, positive and positive, and now I'm factoring the denominator. Okay, x squared can only be x times x, 3 is 1 times 3, and again, positive and positive. That is interesting because normally I would cancel these out, but I'm seeing that the other side has an x plus 3 denominator, so I actually need this x plus 3 anyway. So if I canceled it out, I would just have to put it right back again. So there's no point in me canceling it out. But I guess you don't know until you try. So I need to get like denominators so I can cancel them out. I see I have x plus 3 here, I have x plus 3 here. So this just needs an x plus 1, which I will put in the numerator as well. Now I can cancel out these denominators because they are the same. Wait, before I do though, let's go ahead and mention the excluded values. From the x plus 1, I know that x cannot equal negative 1. From the x plus 3, x cannot equal negative 3. So these are my excluded values. Just watch out that none of your solutions are these. So now I'm going to cancel out these denominators. Without really thinking about it too hard, I'm going to put this binomial times the binomial back to the trinomial from whence it came. So I'm turning this back into x squared plus 5x plus 6, since I didn't actually wind up canceling anything out. Here I'm going to do the distributive property, that's x squared plus x. Alright, this is interesting. So I'm going to subtract x squared from both sides, and I'm going to subtract x from both sides. Alright, it's interesting because both x squares cancel each other out. So this is going to leave me with 4x plus 6 is equal to 0. Subtracting 6 from both sides, it gives me 4x equals negative 6. Alright, dividing both sides by 4 gives me x equals, I'm just going to reduce this, alright, dividing by 2, this is negative 3 over 2. So this is my only x value. Okay, but I need the y value that goes with this. So basically I know my solution is going to be negative 3 over 2 comma something. I just need that y value. I can use either one of these two equations to help me out. I'm going to use the bottom one, and I am going to use my calculator just to save me a little bit of time. Okay, so I have x over x plus 3. and I'm going to use Ask X mode. Whoa, didn't mean to do that. I meant to hit delete. Delete. Let's see. So my x value is negative 3 over 2. So I want to evaluate the function at negative 3 over 2. And the y value is negative 1. So this should be my solution. And there it is. Let's just quickly see how we could solve this graphically. And again, let's use our phone as a graphing calculator. Use the either the website desmos.com, or you can download the Desmos app. Let's see, the top equation, x squared plus 5x plus 6 over, so I'm going to type y equals, alright, so it's x squared plus 5x plus 6 and x squared plus 4x plus 3. Okay, and now the second equation is x over x plus 3. Alright, I'm going to zoom out a bit so I can get a better view. Alright, so we're looking for the points of intersection between these two. And it seems like here is the point of intersection, negative 1.5 comma negative 1. And of course negative 1.5 comma negative 1 is the same thing as negative 3 over 2 comma negative 1. So that's how you would solve it graphically.